Module 1. Pumps and Hazardous Energy. Water transfer operations use large pumps across many applications. These devices can store and release large amounts of hazardous energy that need to be understood and respected. Welcome to the Energy Safety Canada video series on surface water transfer operations. This module focuses on pumps and hazardous energy. We will review pressure as hazardous energy, valves and how they are involved in energy changes, line and engineering design as a tool to predict hazards, and finally, examine the idea of line of fire. Hazardous energy. Pressures involved in water transfer operations are typically thought to be low when compared to traditional applications. But low pressure doesn't mean low risk. Pressure is always a form of hazardous energy. This air test at only 80 psi shows how violent a pressure release can be. A 10-inch hose burst at 150 psi has a force of 52,400 newtons, or 11,780 pounds of force. This is similar to the force in a car accident, where a 200-pound person is traveling at 68 kilometers per hour, coming to an immediate stop against the steering wheel. Always ensure that you are adhering to company procedures for safe work. Follow the manufacturer's equipment operating specifications for safe working pressure and know the limits of the equipment. Supervisors and employers must be sure to provide the appropriate equipment suitable for the task being undertaken. Keep in mind that failures can happen even when you are below safe working pressure. This failure happened by exceeding safe working pressure. A valve was accidentally closed, causing a sudden increase and deadly release of energy. The closing of a valve quickly produced an effect called water hammer, where a sudden pressure change travels down the pipe, causing a vibration and potentially resulting in pipe collapse or even explosion. Take a minute and think about your operation. Do you know what the lowest rated component is? Do you know where that is? Do you know what the maximum pressure will be if the system deadheads? If the maximum pressure is greater than the lowest rated component, that can be a serious hazard. Stop the work and notify your supervisor. Valves. Many kinds of valves are used by industry for various purposes. Understand that valves are specifically selected for a purpose and should not be changed out against the planned type. Some valves may need to be actuated quickly, while others which do so may cause disastrous water hammer effects. Line of fire. Workers can take precautions by knowing the hazardous zones and staying out of the no-go zone or line of fire. The line of fire is a key safety concept to avoid releases of many forms of hazardous energy. It is positioning yourself to avoid moving objects, vehicles, and pressure releases. Be sure to establish barriers and exclusion zones. Secure objects and report hazardous situations immediately that need to be evaluated and changed. Line design. Being out of the way of an energy release is always a good idea, but understanding where those areas are and minimizing them is the preferred solution. Planning and line design are important to minimize hazards. Workers need to understand the basics of the plan and recognize that changes or modifications can have significant consequences. Planning will include a hydraulic analysis to identify zones of pump placement, systems pressures, and potential pressure risks. Following the plan is critical to operational safety and success. Pump placement, valve location, terrain grade, and access all factor into the planning stage. An example of this would be high point positions in the line are identified to allow air bleed off at startup, as low-lying areas may have high pressure zones due to hydrostatic head pressure, even while not pumping. Review the plan and identify areas of concern. Equipment from different manufacturers can vary in function and how it is put together. Be sure to know what the line of fire zones are. Management of change, MOC. When you find a change or deviation from the plan, for example, a different type of valve or the inability to place equipment, the change or deviation needs to be communicated to everyone that might be impacted. This process is commonly called management of change. Your company will have a specific MOC procedure. It doesn't need to be formal or complicated, and it doesn't need to stop all work. It is simply a way to deal with the change between the plan and the field activity. It's the opportunity to make sure everything goes according to plan and to ensure that the change won't impact other areas, systems, or people. Noise. One of the hazards often overlooked when working with pumps is noise. Noise levels above 85 dB requires hearing protection. Hearing protection, whether earbuds, earmuffs, or both, should fit properly. Equipment noise may also result in communication problems. Noise may interfere with the ability to communicate with others. Do not assume others have heard you, particularly when communicating by radio. Ensure confirmation that the correct message was received. There's a great deal to be aware of when dealing with pumps and hazardous energy. If you have any questions or concerns about the tasks you're performing, don't be afraid to ask questions to ensure the safety of yourself and your coworkers.